Okay, for the next part, we are going to find the point of intersection between a circle and a line. So here we are going to have a circle. So there are going to be three cases. So here we have a circle and you are going to have a line here. As you can see from here, we have 2 points of intersection. So this is the first case, which is intersect at 2 points. Okay, so the second case, you have the circle and we are going to have a line here. As you can see from here, it intersects at only 1 point. Okay, one thing that you have to know here, that is, if the line intersects the circle at only 1 point, this line is also called the tangent to a circle. Okay, we are going to cover that part in the this in the next part, but please keep that in mind. If the line intersect the circle at only 1 point, this line is also called the tangent at a circle. Okay, so the next case here is we have the circle and we have a line that does not intersect at all. So here is no intersection point. Okay, so now let's see example 12. So here we have find the intersection between the circle and a line. Okay, obviously it is given to us the equation of a circle and equation of line. So what you have to do here is, let's write that down first. We have x squared plus y squared equals to 24. That is the equation of circle. And we have the equation of line, y plus 2x equals to 5. Okay, so let's put that as the first equation and let's put that as the second equation. So here, okay, let's recap back what we have learned from the intersection point, how to find the intersection point between two circles. Okay, you have to do elimination between the two circles and then you get the equation of line. Okay, but for this part here, if you want to find the point of intersection between a line and a circle, you actually don't have to do this part. Okay, you have to get rid this part. We are going to straight away cover to this part here. Okay, which is we are going to substitute the linear function, which is the equation of line, into the equation of circle that is given to us. So what we are going to do here, we are going to make this as the subject. Okay, we are going to make your y as the subject. Okay, so let's make our y equals to 5 minus 2x. So y equals to 5 minus 2x, and that's going to be our second equation. So we are going to substitute the second equation into equation 1. So we have x squared plus y squared, which is 5 minus 2x squared, equals to 24. Okay, I'm going to expand this. We get 25 minus 20x plus 4x squared equals to 24. Okay, so we are going to rearrange and simplify everything. You should get x squared plus x squared. We have 5x squared minus 20x plus negative 20 minus 24 plus 25. Here we have plus 1 equals to 0. Okay, so you have a quadratic equation. So basically it is the same thing from this part here, but this part we are going to skip. Okay, you are going to straight substitute the linear function into the equation of circle. So what we are going to do next is, since the question said find the intersection point, so what we are going to do is we are going to find the x first. Okay, but if you put this into your calculator, you get decimal point. Okay, so that means the quadratic equation cannot be factorized. So remember the three part how to find the quadratic equation. We have factorize, and then we have the completing the square, and the last one we have the quadratic formula. Okay, since you cannot factorize this quadratic equation, what we are going to do, so let's do the quadratic formula. So you have to show this part. So here our a is equals to 5, b negative 20, c is equals to 1. We are going to substitute into the formula, quadratic formula, which is negative b square here is, this one should be negative 20x. Okay, so negative 20x square, sorry, negative 20 square. So remember the formula is negative b square plus minus square root b square minus 4ac over 2a. Okay, so that is your quadratic formula. So we are going to substitute that into here. So square root b square minus 4ac. So we have minus 20 square minus 4 plus times 5 times 1 divided by 2 times 5. Okay, so here we get the answer x equals to 20 plus minus square root 80 over 10. Okay, which is we'll get the first answer, x1 equals to 3.95 and the other one x2 equals to 0.05. Okay, so you have your x. So what we are going to do here is we are going to substitute the x into the function here. Okay, the linear function here. So when x equals to 3.95, y equals to 5 minus 2 times 3.95, which is we'll get negative 2.90. And the last one here, we have an x equals to 0.05. Your y is gonna be 5 minus 2, 0.05. Here's you are going to get the answer 4.90. Okay, so very simple. But remember, the question asks for the point of intersection. Don't just leave it your answer like that. Make sure you write your point of intersection in coordinate form. Okay, point of intersection is our x is 3.95, the y is negative 2.90, and the other one is 0.05, and the y is 4.90. Okay, so that's gonna be our final answer. Okay, so basically almost the same thing as the point of intersection between two circles, only we are going to skip the first part, which is the elimination. Okay, alright, so now let's do one more question. Find the coordinates of the point of intersection between the circles and the line. Okay, so this one here you can do it by yourself, which is I'll give the answer 5, 2 and 3, 4. Okay, so very simple, just substitute the equation of line into this equation of circle. So you are going to get a quadratic equation. So just put in your calculator, get the x or the y, and find the point of intersection. Okay, so the next part here, example 14. So a little bit different from what we have done earlier. So show that line y equals to x plus 20 does not intersect x square plus y square equals to minus 144 equals to 0. Okay, so from here you know that whenever the question said does not intersect, that means you have a circle and a line that does not intersect. Okay, so what we are going to do here, so I'm going to write something here. Okay, how to find, okay, as you can see from the next question here, find the shortest distance between the line and the circle. Okay, so what does it mean by that? So let's go straight here. As you can see from here in the box here, short distance or perpendicular distance. Okay, short distance or perpendicular distance. So what does it mean by that? So I'm gonna erase this part here. So short distance or perpendicular distance, this is from line to center. Okay, a short distance from a line to a center. So here you have the circle, here you have the line, here you have the center. So this is what we call as the short distance, which is we label this as our S. Okay, sorry, we label this as our D. Okay, as D. So there are two cases. Okay, there are two cases to solve this problem here. So let's write that as case 1. Okay, you can ignore this part here. or let's put everything on here. Okay, bear with me for a second. Here. Okay. Okay, so let's put that here. We have the short distance. Okay, the shortest distance. So as I said before, we have two cases. The first case, which is the shortest distance, the question asks for the shortest distance between the line, a line, and the center. Okay, so what does it mean by that? So we have a circle, we have the line. Okay, so the shortest distance between the line and the center. So here is your center. So this is gonna be the shortest distance. Okay, so sometimes that is for the if there is no intersection point between the center, between the circle and the line. Okay, sometimes it can be like this. Okay, so this is your center. So the shortest distance between the center and the line is this part here. Alright, so the second case, the question will ask you the shortest distance between line and the circle. Between line and circle. So let's draw that part. So we have a circle. Okay, not a circle there. We have a circle. Not a circle again. So make sure this is a circle. Nope. Sorry. Okay. Why? Okay, now we got our circle. So here is the line. Alright, so shortest distance between line and a circle. So this is gonna be the shortest distance between the line and the circle, right? We have the line, we have the circle, so this is gonna be the shortest distance. So let's label that as S. Okay, which is, here we know that this is the center. This is the shortest distance between the line and the center, okay, which is from this formula here. Okay, so let's label that as D. Okay, so let's label that as D. And you also know one thing here is this is the radius. Okay, this is gonna be the radius. Okay, so how are we going to find the shortest distance between line and circle, which is this part here? Okay, you have this, which is distance between line and center, minus by the radius, you'll get the answer for your S. Okay, so the formula is S equals to D minus R. Okay, one more time. If the question asks shortest distance between line and circle, which is that is your S. Okay, you want to find this part here. So you have to find the D, which is distance between line and the center, by using this formula. And then you have to minus by the radius, you'll get this answer here. Okay, so just keep that in mind. We go to the question here. So the question asks to show that line y equals to x plus 20 does not intersect circle x squared plus y squared minus 144 equals to 0. So you know that if the question said if the type of intersection means there is no intersection point, you have to show that the discriminant b squared minus 4ac is less than 0. Okay, to show that you need a quadratic equation. So what we are going to do is we are going to substitute the line, the equation of line, into the equation of circle. Okay, so let's put this as the first equation. This is our second equation. So we are going goreng. We are going to substitute 1 into 2. So here we have x square plus y square, which is x plus 20 square minus 144 equals to 0. Okay, simplify, expand everything. We have x square plus 40x plus 400 minus 144 equals to 0. So here we have 2x square plus 40x. 400 minus 144, we have 256. Okay, whenever you have a quadratic equation, always simplify. Okay, so this one we can simplify by dividing everything with 2. So here we have x square plus 20x plus 128 equals to 0. Okay, we have our quadratic equation. We want to find the type of intersection. Actually, the question doesn't say find the type of intersection. The question said show that the line here does not intersect with this one here. So how are we going to show? Is basically use the b square minus 4ac method. Okay, so here we have b square minus 4ac. So our b here is 20 square minus 4. Our a here is 1. C here is 28. Okay, so here if you substitute this into your calculator, you'll get negative 112 less than 0. Okay, so since the question said show, you have to do your conclusion. So since b square minus 4ac less than 0, the line y equals to x plus 20 does not intersect with the circle. Does not intersect circle. What circle? Okay, this circle here. Okay, settle on the first sentence here. So we are going to see this part here. Hence, find the shortest distance between the line and the circle. So we know that the circle and the line does not intersect each other. Okay, so we have a circle. A circle here. Why my circle like that? I think I have a problem drawing a circle. Nope. Okay, just bear with me, guys. Okay, here we have the circle. So, and the line. Okay, so now the question said shortest distance between the line and the circle. So that's gonna be this part here. Okay, which is, this is your S. Okay, so we are going to find the S. So what is our S? Do we know the radius of the circle here? Okay, so to find S, we need the D and we need the R. Okay, because we have to minus those two things. So do we have the radius here? Okay, as you can see here, we have x square plus y square equals to 144, which is in standard equation with the center at the origin. Okay, 0, 0. Okay, so let's write that down. We have x square plus y square. Bring 144 to the other side. So this is the standard equation when the center is at the origin. So you know that here is our r square. Okay, we compare this x square plus y square equals to r square. So we know that our r square is equals to 144. That means our r is equals to 12. Okay, and from that equation also we know that the center is at the origin, which is 0, 0. Okay, one thing we find here. Okay, so here is the center. We found our r. Here is the r. Okay, so the only thing that you have to find here is this part here, the distance between the line and the center. Okay, which is we call as D. Okay, how to find the distance between the line and the center? What you are going to do is we are going to use this formula here. Okay, D is equals to modulus AH plus BK plus C over square root A square plus B square. Okay, so for this equation here, this part, your A, okay, how am I going to write this? Okay, so here, your A, B, and C, okay, the yellow part is from the center. Sorry, is from the line. From line. Okay, the blue part, which is your H, your K, is from the center. Okay, from center. Okay, that means the yellow one, this one, your A, B, is also from line. Okay, so what are you going to do for the equation of line? You have to make it as AX plus BY plus C equals to 0. Okay, so your equation of line has to be in this form. So your A, B, and C is from this here. Your H and your K is from the center. Okay, so let's see. Now we have the equation of line, which is y equals to x plus 20. So remember, you have to put it as ax plus by plus c equals to 0. So what we are going to do here is we have the equation of line y equals to x plus 20. Okay, so we are going to rearrange this as ax plus by plus c equals to 0. So that's going to be x minus y plus 20 equals to 0, right? So you have your a is equals to 1, b equals to -1, and c is equals to 20. Okay. So what you are going to do is you are going to substitute into that formula, the distance, the d formula. So which is, the formula is d equals to modulus ah plus bk plus c over with square root a square plus b square. Okay, so we are going to substitute. Remember, your a, b, and c is from the line in this form here. Your h and k is the center. So we are going to substitute. Our a is 1 times by the center, which is 0, plus b is -1 times the center y is 0, and c here we have 20 plus 20. Okay, modulus over square root a square plus b square. So a is 1 square, b is -1 square. So here is gonna be 1, 0 plus 20 will get 20. For the denominator, we have square root 2, and that's gonna be your value. Okay, the shortest distance between the line and the center. So we have the d here, we have the r here, so to find your s is d minus r. Okay, so the answer here is shortest distance between line and center, which is we call as s, equals to d minus r. So we get the answer for d 20 over square root 2, and the r, our r here is 12. Okay, so this is our d. Okay, our r is 12, so you just put everything in your calculator, you get the answer 2.142, and that's gonna be the shortest distance between line and circle. Sorry, line, yes, line and circle. So this is not center, line and circle. Okay, a little bit complicated, but it's okay, not too hard. Just a recap one more time. So for shortest distance, we have 3 things: distance between line and circle, which is we call as s. Second thing, we have distance between center and a line, which is we call as d, and the last one we have the radius. Okay, so to find here s, we have to minus d minus r. Obviously, this one here minus by this, we get this part here. So to find the D, which is the distance between line and center, you have to use this formula here. Okay, we have to use this formula here. So your A, B and C comes from the line, okay, from the equation of line in this form here. Okay, so the H and K is your center. So substitute everything, you'll get the distance between the line and the center, and then minus by the radius, you get the distance between line and circle. Okay, so that's it. I'll see you guys in the next video, but yeah, okay, thank you.